Welcome back to Algebra 1. We are doing Chapter 6, Section 1 in this book, solving one-step linear inequalities. Now, remember I told you the most important thing you were going to learn is how to solve for x. And then once you do it, you'll do it from now on, but you're really just practicing it. And then you might learn more parts to it, and when x is in different weird situations, but you're basically solving for x. And now we're going to take all of our solving for x knowledge and apply it to inequalities. And just to remind you, inequality is Pac-Man. Now, when I was a kid, inequality was an alligator, and I would draw him with the teeth, and he'd have little ridges on his back like a dinosaur, and it took me a long time to draw him. And then he was a baby bird, but baby birds have no scope for the imagination. So now he is Pac-Man, and Pac-Man always wants to eat the ghost or whatever is more. You know Pac-Man, he's hungry, eating those fruits. I think of Pac-Man going walk, 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 walk. All right, so we have 6 and 8. Which one does Pac-Man want to eat? He wants to eat 8. So there's Pac-Man. He's going to eat 8. So that's how inequalities work. They always just want to eat the one that's more. Okay? So now we're going to learn we're going to review how to graph inequalities, and then we're going to learn how to solve for x in an inequality. And you're going to find out it's easy. You're going to do great. All right, so x is less than 2. So how we graph that is we go to 2, and because it's less than, we draw what I call as a donut. If it had been less than or equal, then it would be a dot. So it's dots and donuts. Now I had a student once say it needs to be coffee and donuts, but that's too confusing for me. I'm going dots and donuts. Because it does not have the equals underneath, it's a donut. So I go to 2 and I draw my donut, and x is less than 2. So it's here on the less side, and we color, and this is what you're going to use your colored pencils for, including the arrow, everything from the donut back. Okay, let's do this one. X is greater than -2. We come to -2, we do a donut because it doesn't have the or equal sign, and now x is greater. It's the big one. It's the one Pac-Man wants to eat. So we color the greater side. So we're going to color this side, including the arrow, with our colored pencil. Okay, let's do this one. X is less than or equal to -1. We go to -1. It's got the or equal to. We draw a dot. It's less than, so we do the less side and color it in, including the arrow. Let's do this one. X is greater than or equal to 0. So we go to 0. It's the or equal to, so it's a dot. And x is bigger. It's on the greater side. So we color the greater side, including the arrow. Now, of course, when you do this, you will use a ruler and be really neat. Okay. Now, here's a word problem. It says Sue. I went running this morning, and Sue is going faster than I did. I bet it's because she's a teenager, and I'm a middle-aged woman. All right. So Sue ran a race. She ran a 2-kilometer race, and her time was 8 minutes. At one point in my running, I got to a 5-minute 5K and thought I was doing awesome. Sue was doing 4-minute Ks. I was doing a 5-minute K. So I almost got to Sue pace at only one point when I was feeling warmed up and fast and not yet tired. So anyway, the formula for speed is distance over time. And my story about this is I was a brand new teacher. I was so excited about inspiring kids to love science and math. And I put this formula on the board and I said, how can we remember this? This formula is something like, please excuse my dear Aunt Sally. And one of my kids looked at me, and the kid looked 25 years old. I know he wasn't, and it was like my age, and he looks at me dead face and said, dead science teacher. All right, so I always remember this is the dead science teacher. And that's why I thought this is going to be harder than I thought. All right, so speed is distance over time, so we put Sue's distance, 2K, over her time of 8. We can reduce that she was going 1/4 kilometers per minute was her rate. But they wanted an inequality written to represent the people who were faster than Sue. Ones whose time was less, or whose, this would be if it was the time, but this is the rate, and so their rate would be greater than Sue. Her rate is slower, their rate, so we'll make it S instead of X. Their speed is greater than Sue's, so this is an inequality, showing that. If it was time, their time would be less than Sue. Their time would be less than Sue because they were faster, but their rate was greater, their speed. All right, let's do another one. Now we're going to do an equation. All of that you probably learned in middle school, except maybe that. But this is new. What about if x is not alone? We ask ourselves, why is x not alone? On its side of the inequality, it has a -3. We do the same thing. What's the opposite of -3? +3. What we do to one side, we do to the other. These cancel out, and x is less than 8. Now, so you see it is like it is just like if it was equals, except one thing, and it's really important, okay? And this is it. I got my hands out ready to clap. You do it exactly like an equals unless you multiply or divide both sides of the inequality by a negative number. Then you flip it. You flip the inequality. Okay, let me repeat the rule one more time. It's exactly the same as equals unless you multiply and divide, not add and subtract. Multiply or divide both sides of the inequality by a negative number. That's the only thing that's different. Okay, got it? So let's do this one. Why is x not alone? It's got a +6. So we're going to do the opposite, -6 to both sides. Do we flip it? No, this is -6. It's only if we multiply or divide by a negative number. These cancel out, bring down what we didn't mess with. 10 minus 6 is 4. Whoop, whoop, whoop. More fun with sound effects. All right, here's another one. X plus 5, we're going to do -5 on both sides. Why is x not alone? It's got a +5. Let's do the opposite, -5. Those cancel out, bring down what you didn't mess with. Do we flip it? No, we subtract it, not multiply or divide. 3 minus 5 is -2. Now they want us to graph this one, so it's or equal to, so it's a dot, not a donut, and x is on the greater side. See how Pac-Man wants to eat x? So we color the greater side, including the arrow. I made a timeline there because I was running out of a timeline, a number line because I was running out of space. Okay, here's another one. Why is x not alone? It's got a -4. What's the opposite? +4. What we do to one side, we do to the other. Those cancel out. We bring down what we don't mess with. We don't flip it. -2 plus 4 is 2. So we got, it is not or equal to, so we do a donut at 2, and x is on the less side. It's a less than. Easy peasy. All right, let's do another one. Why is x not alone here? It's being multiplied by half. What's the opposite? It's 2. So you can also think of this. This is the same thing as x divided by 2. Mathematically identical. So really what's happening here is x is being divided by 2. What's the opposite of divide by 2? Multiply by 2. What you do to one side, you do to the other. Those cancel out. Do I flip it? No, because 2 is positive, not negative. So x is greater than 6. Let's do this one. Why is x not alone? It's being multiplied by 3. What's the opposite? Divide by 3. What I do to one side, do to the other. Do I flip it? No, 3 is positive. So x is less than or equal to 3. Whoop, whoop. Why is x not alone? It's being divided by 3. What's the opposite? Multiply by 3. What I do to one side, I do to the other. These cancel out. So x is less than or equal to 36. Do I flip it? No, 3 is positive. They wanted us to graph this one. So we're going to notice how I changed the timeline. I didn't go from 1 to 36. Then I made it tens, 10, 20, 30. So 36 is a little over half. It's or equal to, so it's a dot, and x is on the less than side. Okay, let's do this one. Why is x not alone? It's being multiplied by an understood -1. So what's the opposite? Divide by a stood -1. What I do to one side, I do to the other. These cancel out, x comes down. Do I flip it? Yes, because I divided both sides by -1. That comes from turn up the stereo, blast the stereo louder, and flip it. Flip it. Okay. All right. So x is greater than -4. How about this one? Why is x not alone? It's being multiplied by -2. We divide both sides by -2. Those cancel out. Over here, 6 divided by -2 is -3. Do I flip it? You bet. So this is greater than or equal to -3. And our last one, why is x not alone? It's being multiplied by -4.2. So we divide both sides by -4.2. Those cancel out. And we flip it. Because it's dividing by a negative. And that's 1.5. Go over here to 1.5. It's a donut. X is less than. Color it on that side. All right, you got to practice these. Watching me do it and you doing it is a totally different skill set.